15, I believe, is actually a real doozy. I don't always put these in order of difficulty. And it is a problem where we have to do a retrosynthesis, where we have to think backwards from this product to this starting material here. And we're supplying the reagents in between. Now, luckily with multiple choice, you're given the exact reagents, so you don't have to have an exactly clear picture of those reagents in your mind, but you should try to work through it on the paper still. Notice I've covered up the answers, no answers here, so it's a lot more than just knowing the reagents here. There's a lot of reasoning that goes into every problem in organic chemistry. That's where the real difficulty comes in, not just in memorizing reagents. But you do have to have a basic understanding of what reagent to add. So we start out with that. That's number one step here. Step one, figure out what reagent goes into this. NO2, you should think nitric acid, and the oops, almost wrote it out, sulfuric acid. Over here, this one's a little bit trickier. Here in our thinking, let me put it over here, we may think Friedel-Crafts. Friedel-Crafts here, remember, FCs, is any time we put a carbon onto the benzene ring. Here the C stands for carbon. Right there, there's a lot of times that's a Friedel-Crafts in an electrophilic case. So let's say we thought of this reagent. This is the wrong reagent. Got to remember that this is the wrong reagent. If I add benzene to this, here's what you're going to get. You're going to get an isopropyl group, because you will see this shift over. 1,2 hydride shifts will get you here. So you may think that. Hopefully you remember with the hydride shift, that's not a possibility. So the only other possibility then is to add one, let's count 1, 2, 3 carbons with an acyl group. That's what I went over a minute ago. And you would use the acyl group here with aluminum chloride, and that could put 3 carbons on there. Now another reagent goes with this acyl group here. If we're going to get to this step, we should also think of 2 other reagents. A mixture of hydrazine so we could think of that, or the zinc mercury amalgam here. That's the acidic conditions. Now you may forget hydrazine. Does it have HCl? Does it have hydroxide? It really doesn't matter as long as you see that's hydrazine. Same thing over here. Zinc mercury, does it have HCl? Does it have sodium hydroxide? Doesn't matter. You should know this zinc mercury amalgam here in this case is going to take an oxygen, that one, off of there. So the next line of reasoning, that was all step one, find the reagents that could put those things on there. Next line of reasoning is to observe their orientation on the ring. So relative to each other, 1, 2, 3, we've got the meta substitution right here. Okay, and that should mean that we put a meta director on first. You hear that conclusion? Meta relative to each other. Line of reasoning. Meta director goes on first. That's the line of reasoning. We've got a stipulation here, though, especially with this thing here. You cannot carry out Friedel crafts on a ring that has nitrogen on it. One nitrogen, right here. And NO2 is the nitrogen here. So I can't carry out the Friedel crafts after I've done this one. So you can't think that the nitro group goes on first. But luckily, in our reasoning, maybe we didn't arrive there at the beginning, but hopefully you did. Luckily, in our reasoning, we've come up with this carbonyl, which is also a meta director. Okay, there's lots of sequence steps here. Very easy to get confused in one's mind when you've got a very complicated sequence of events. So always draw out, step by step, every reaction in the forward direction, so there's less chances of getting confused of what's going to occur and where it's going to go on the ring. There's a lot of oops, forgot the chlorine. There's a lot of backwards thinking. You've got the concept right, but you apply it in the backwards direction, in the opposite way that it should be. The only remedy is to really carefully work through it step by step. One step at a time. Always take problems one step at a time. So here we have the carbonyl that got added. We got 1, 2, 3 carbons. And once we add that on there, we see it's a electron withdrawing group. And that could orient to the meta position right here or right here. Those are equivalent, so there's no need to show a reaction with both sides. Okay, at this point, not sure what the answer choices are providing yet. At this point, we can go ahead and add our reagents, observe what happens. We get that NO2 right here. And we see we're almost there. All we have to do is remove that oxygen. We can add our reducing reagent right here, which I believe for this problem it's zinc, but we're looking for zinc or we're looking for hydrazine at this point, just like we wrote out above. Either one of those and we get this and there's our target molecule right there. The oxygen has magically disappeared. Okay. Look at the answer choices and try to find that sequence. Here, I found for you the acyl group is kind of hidden. That is the acyl group that's being added. Then we add the nitric acid. It goes to the meta position. And then the zinc mercury amalgam right here takes the oxygen off. Okay. That is the right answer choice then. A is the answer. Let me show you one other thing here with this problem. Let's say we take a side route and take off this with hydrazine or zinc, whichever one. then we're going to get the alkyl group here. And if we try to add nitric acid to this, like that, this is what's going to happen. We'll get a mixture of two products, mostly the para, right here. So there's a wrong sequence. This is the wrong pathway right here. That answer will always be shown in these cases. The wrong answers will always be shown when they're very close. Let's see here. What wrong answers do we have? Well, here in this case, the wrong answer is where we put the alkyl group on there, and then it goes to the para position. There's one other thing wrong with this. Do you see it? They're going to get the shift. Be able to spot those shift ones really quickly. That's the wrong. So wrong for two reasons. We get the shift here, and we get isopropyl group added to the ring. And then two, it's added to the para position. On D here, a nitrogen is added to the ring first. So we cannot carry out Friedel-Crafts in the second step. Those are really tricky. So that's a wrong answer. And B, sometimes I do this, sometimes I don't as a wrong answer. Make sure you add the right number of carbons. This really is a play on eyesight. Got to look at every detail in organic chemistry. Look closely at the atoms that are there. Those chemicals mean something. Chemical formulas mean something. Here we have CH3, CH2, and it looks like another C right here, but that's really a Cl for chlorine. So wrong number of carbons, and it's a Friedel-Crafts alkylation right after a nitro group is added to the ring. That is impossible. Here, watch out for those wrong answers.